Hello everyone, I'm Snaith. Today I am going to present our project on generative AI for cyber threat hunting in 6G embedded IoT network. This work is based on a cyber threat hunting, and my goal is to explain the problem and the proposed solution and how project contributes to solve cyber threat issues in the next generation networks like 6G. The project introduces a hybrid approach that used to combine the GAN and the transformer for cyber threat hunting. GAN. GAN is a generative adversarial network which is used to create a synthetic attack data by using normal data. This improves the model to train and explore many different attack scenarios. And the transformer model. The transformer model is used to classify the IoT traffic, whether it is a normal or attack. The reason is this is important because the traditional model cannot handle large scale and the complex 6G IoT traffic. This proposed solution improves the detection and the accuracy about 95%. This is a major achievement in our project. And the problem starts with growing number of cyber threats in 6G environment, because 6G has high bandwidth and fast network, so attackers are easy to attack on the IoT device. So there are some common threats in IoT. First one, DDoS. The DDoS is a common user attack which sends enormous number of requests to the server, which damage the server and IoT device. And another one, a malware, which can steal or damage the data or information. The traditional models are not very accurate and they does not scale this all. So we need smart approach that can handle these challenges in real time. Scope of our project. Our project focus on core threat detection. Within scopes, we are implementing the transformer based model. We are also building the multi-class classification system, and we are using the Edge-IIoT dataset, which is larger dataset and which consists of three kinds of files: normal file and attack file, and other one is model file, and model file consists of other two files, uh, which are machine learning dataset file and deep learning dataset file. So we are using deep learning dataset file and we are evaluating the performance. And outscopes, we are not using full GAN model yet, and also we are not doing decentralized training, and we we are not moving the full prediction yet. The focus is to build the research level with relatable results. The work is useful for telecommunication providing and the internet providers and smart cities and infrastructures and healthcare. Where there is a cyber security, this project is important. These are the business use cases. Now proposed solutions. Our solution has three main parts. The first one, GAN based data augmentation, and the second one, transformer classification, and the third one, scalable security framework. And now we are going to the first one, GAN based data augmentation. GAN is a generative adversarial network, creates the synthetic attack patterns using Edge-IIoT dataset. This makes dataset bigger and complex, which helps the GAN to perform well. And the second one, the transformer classification. The transformer learns patterns in the network traffic, and it is used to detect whether the traffic is behaving normal or attack. And the second one, scalable secure framework. It ensures the system works in real-time 6G environment, and the model achieves over 95% accuracy. At the same time, this keeps computational cost low. This slide shows the system architecture of our project. And now the data of IoT devices are collected to the dataset and send the dataset to the pre-processing and training and testing. And at the same time, the same data set is sent to the GAN, Generative Adversarial Network. The pre-processed and trained data is sent to the transformer. The transformer will learn the patterns and behavior of the normal and attack. And at the same time, the generator or the generative adversarial network also creates the synthetic data with the help of generator and discriminator. The generator is used to generate the random noise and creates the attacks in the dataset, and this discriminator is used to find or classify whether the data sent from the generator is attack or real. It continuously detect. When the discriminator is misses to detect this, the loss function will be increases. So the synthetic data will be created. The synthetic data is combined with the real data and sent to the transformer, and the transformer will train with this synthetic data and with the number of attacks. And the when we give our model data, IoT data to the transformer, it will easily classify whether it is normal or attack and send output to the user. This whole pipeline makes the system architecture scalable. To conclude, we first reviewed the generative AI for cyber threat hunting in 6G embedded IoT networks, and we also defined the problems of raising cyber threat in 6G embedded IoT networks, and we also proposed the hybrid models like GAN plus transformer based models as a solution, and we also explained our architecture, system architecture and workflow. And the next step, and we are going to implement the GAN plus transformer model, and we are going to train this model on IoT data sets like Edge-IIoT, and so many data sets are there, and we are going to train on them, and we will validate the result using accuracy and precision and recall, and finally we will prepare and present the result in the next milestone. And thanks for listening. I'm happy to answer any questions.